Okay.
All right. Who can read my target for me today for science? Have you read it yet? Read it for me.
Science.
Mm-hmm.
I can describe a model magnetic field in relationship between
Okay. We've talked a little bit about North and South Pole. I mean, we talked for a whole day about North and South Pole. A little bit about magnetic fields. And you guys tried to figure out how you might draw that just by feeling the magnets. Today, we're going to look at that. I have a treat today. It is fabulous. Yesterday, I found some iron shavings. You know where I got them?
Where?
I got them at a car place.
A car place? I didn't know they had those.
I wouldn't have either. I got them at a car place. How cool is that?
Wait, what car place?
So today we're going to use our shavings, our iron shavings. Why would you think I would choose iron, Aaliyah?
Because it's made out of iron?
Well, because it's made out of iron, but why would I choose iron?
Because it's a magnet?
It's attracted to magnets. Yes. We're going to use iron shavings to try to actually see the magnetic field. A magnetic field, though, is kind of like the wind. Do you look outside? Can you see the wind?
Nope. No.
What do you think? Well, you guys might not be able to see it because the thing's shut. What do you think you could see that proves that there is wind? What could you see?
You could see the trees moving.
Trees moving.
Like leaves moving.
Leaves blowing.
There's a way that you can actually see when there's a tornado.
Oh, okay. Talon?
Grass moving.
Grass blowing.
And say if it's raining, you go outside, you can feel the rain.
The rain going kind of sideways. Zara?
You can feel the wind.
You feel it, right? Okay, hands down. Today, we can't see the magnetic fields just when you look here. Do you see a magnetic field? No. You can feel them though, right? When you put your magnets close together. Today we're going to try to see the magnetic field. We're going to do an experiment so we can kind of see it. Hands down. So you can kind of see it a little bit, okay? Let's see. We're telling about the relationship between the magnets. Some of you will get a north and a south. You'll work with a partner on north and south. Others will get a north and a north, okay? So you're going to look at the relationship between north and south magnetic fields and north magnetic fields. You're going to have a chance to draw what you think it will look like before you even try it out, okay? So today we want to draw those magnetic fields and see what they look like and see the relationship between the magnets and how it changes or doesn't change the magnetic field. You guys excited?
Yeah.
I'm so excited. This is so much fun. So much fun.
My dad told me about this last night.
He told you about it?
Yeah.
Oh my goodness. You're a great dad. Talon?
Will you tell us how we're getting north and north, or
You'll
will we just figure it out?
It's on here.
Oh.
It's written on here.
Oh. When you said you had iron shavings, I knew what was going to happen because my dad has a friend that works at KLI, which is a car place, and I brought a magnet back there because I
Don't ruin it for people though.
a whole load of magnets.
Okay. Trevor's got some schema. He's not going to tell you. You're going to have to figure it out on your own, okay? Okay, when I give you paper, I want you to go to your desk. We may have to do some shifting because we've got a couple people out and you need a partner. I want you to work with a partner across from you again, okay? So when I give you paper, head back, put your name on your paper, and don't write anything else. Is your hand up? We'll figure it out. We'll figure it out. I like how those friends went back, straight back, and got started silently. Come get them. Scoot it on the floor. I put it in my lap and I dropped it. Here we go. Oh, Lexi said, I'm so curious. I love that. That's a scientific Name on the front. Name on the front. Once you get your name on the front, we're going to make our hypothesis. We're going to guess number 1 and 2 where it says hypothesis. It says, what do you think the magnetic field would look like between these two magnets? Draw it. Draw what you think it might look like. Shane, I want you to sit in front of Jace, please. Jason, I want you to sit in front of Trevor Elliott, please. Draw that magnetic field. What do you think it might look like? I put the magnet there for you so you can draw the magnetic field.
I said, I'm putting like a magnetic field, like facing off some place, and they won't turn around.
Okay. As you draw, I'm going to put something on your desk. Every eye on me. Raise your right hand. Repeat after me. I will not open the bag. The whole time. Okay, hands down. I'm very serious. Okay, we can't open these and get them all over the place because they can be kind of sharp. Okay, if they're just laying around and we get our hands all in them, you may not open the bag. And please do not try to like squish it around and break it open. Okay, I'm really serious about this part. Okay, don't touch it. Keep drawing your magnetic field.
Remember the label.
Hannah said, remember to label. Your magnet's already labeled for you. They're already drawn for you, so you don't have to redraw the magnets. You just draw the field that you think will happen. I'm going to give you about 1 more minute. Don't touch them. 1 more minute to draw what you think is going to happen. Yeah, 1 and 2. I already drew the magnets for you, so you draw what you think is going to happen.
Don't do the same thing with your
On your magnets. It's okay. Do it for the next one. Somebody share with me what you think might happen on that first one, north and south. Or north and north, sorry. North and north. Anna, what did you think?
Well, I drew a picture of the magnet pushing away.
Oh, she kind of drew pushing away from each other. Okay. What else did you draw? What else did you draw?
I draw how it was pulling, and then one hand it said pull away, and then the other one saying no you.
Okay. What do you draw? What do you think about north and south? What do you think about north and south, Karen?
I think they're gonna
Come together. Why do you think that?
because north and south both
They attract. Thank you for using good vocabulary. She says north and south poles attract. What about those north and north? What do? They repel. Okay. You have a drawing of what you think will happen. The next thing we have to do is we have to test it. We have to test and see what's going to happen, okay? You're going to have a card. It will have either south and north, or it'll have north and north, okay? You'll have to draw down below where it says record your observations. You'll have to draw down below what you see that magnetic field looking like, okay?
Yes, ma'am.
First thing I want you to do is I want partner one's right here. One's. Grace's side is 1. One's. Okay? Partner 1, pick up that card. The card. The baggie. Okay, you know, borrow yours real quick. Here's what we're going to have to do today. As you work today, you're going to have to get those black shavings to go on top of the card and shake it around so they're kind of spread out on this card. Let me show you what I mean. See how I'm shaking it? Okay, look. See how they're kind of spread out around on my card. Get them spread out the best you can. It kind of helps if you tap it a little bit and pick up and shake it side to side. Hold on, let me show you. See how they're kind of spread out on my card? Spread out on the card. Okay. The other kind of spread out. You want it pretty good spread out. Practice doing that, partner one. I think it's, yeah, that's perfect. Got it? Okay, if you shake them all down to the bottom and then like turn the bags like this and get them all down here, then you can just shake it around. Okay. Pass it to partner two. Pass it to partner two. Let them practice that.
It's just fun to all
Jessica County, you play basketball?
Put it back down. Put it back down. Put it back down. All right. Here's what we'll do. I will give you a note card. Grayson, have a seat right here and tie and carry group. I will give you a note card. I want you to look at your note card and see if you have north and south or north and north. Do not put the note card by your baggie. Keep them separated. So partner one, put the baggie in your hands. Partner two, I will give you the note card. Okay? See what you have.
Yeah, you were doing it.
Grayson, no, the paper off my, oh, Frank's all this stuff. I got it. Okay, partner one, get your baggie ready. Get your baggie ready. Spread those iron shavings around on that card. Partner two, hold your note card with your magnets down flat. Put your note card down flat. Okay, partner one, we'll do it the first time, okay? Partner one, when you have your shavings spread out, pick it straight up. You're going to set it straight down on the magnets. Don't shake it around. Don't move it around. Just pick it up. Set the shavings right on top of the magnets. Okay. You may now shake it around just a little bit and try to get a couple more on there. See what happens.
Awesome! Wow! How is it doing that? Whoa!
Because it's holding the iron.
That's cool.
Let's do it.
Okay, guys, big question. Some of you have north and north, and you notice something happening there between the magnets. Others of you have south and north, and you notice something else happening between the magnets. I want you to draw a picture of what you notice happening between the magnets, that magnetic field. What do you guys have? Okay. You can't shake it, like, don't pick it up, okay? Okay, let's spread out. Wow, come on. Okay, here we go. Look what happened between your magnets. But look what's happening between your magnets. Okay, Bree is drawing her magnets on her observation paper. I want you to notice what happens around the magnets and what happens between them. Look between the two magnets. Cheyenne, you're drawing. Between the two magnets. That's yours right there. Kerrigan's got yours. What magnets do you have? If you have a question about what's going on between, Those lead shavings are showing you the magnetic field. Guys, those lead pieces are showing you a picture of the magnetic field. Draw for me, oh, yeah, iron, sorry. Iron pieces are showing me the picture of the magnetic field, okay? You're drawing the picture of the magnetic field based on what you see. I want you to pay close attention to what's happening between the magnets. Don't show them, they haven't done it yet. They have a different one than you, don't show them. Here's one.
It was sticking with the first draw picture.
Okay, what's happening? Let me see if I can. What's happening between the magnets? Make sure you label your magnets on your drawing. Some of you haven't labeled it and you're not going to know.
And there was this big
Okay.
iron that was just
Tell us, show me the magnetic
on the
field.
dark side
Draw.
out.
You can leave that. Okay, draw the
Because I guess most of the iron.
Raise your hand if you have north and south. I want to see what you guys are noticing between your magnets. Once you've stuck it down, I want you to take your hands off of it. Okay, I don't see the field though. I want you to draw for me what the iron looks like. Draw for me what these iron shavings look like. So here's one of your circles, and here's another one. No, this is the one that you're supposed to be drawing first. What's happening between them? Take it off, because you can't see what you take off. There's a huge space where there's no lead. Some people are seeing different things between their magnets happening. I'm not going to tell you yet. But I want, when you make your drawing, here's what I want to see in your drawing. Okay? I want to see your magnet and your magnet. I want to label whatever they are. They're north and north, write it. And I want to see your magnetic field. Okay? Show me. I'm not going to draw between because I won't give it away. Okay? Show me what it looks like. Where the iron is attracted to your magnet. That's that invisible field that we're looking at. What's up? Okay. Here's what we're going to do. Here's what we're going to do next. Okay. I need you to leave this on there. Okay? So I can see it. Look between the magnets. What's happening? Here's a circle. Here's a circle. So that's what I want to see. I want to see that. Okay. Partner 2, pick up the baggie. Pick it up and hold it. People at this table, right here, switch with the people next to you so you have the different note card. So if you had north and north, switch to north and south. You two switch. You two switch. And you give me yours. I say pick up the baggie, not potato. Okay. Partner 2 will be in charge of shaking the baggie and getting it ready. Get ready, that on top. So shake the baggie and get it ready. Get your iron shavings laid out. Ready? 3, 2. Okay, here we go.
Go. You're gonna
Get your iron shavings on that white paper. Once you've got them laid out really flat and spread out, I want you to lay it on top of your new card. See what happens? Notice which two magnets you have. It didn't do the same thing.
Sort of like the same thing, but there's paper.
Look between you guys. Here's your circles. What's happening between them? Here's your circles. What's happening between them?
This must be like the north.
They're north and north. That's what they say on them. That's what they are.
Like this must be like south, like the
Iron isn't a magnet though. Iron's just attracted to it. You have north and north magnet, and we're looking at the. We're looking at the field between them. So yours, there's nothing. There's no attraction between them. Yours, there's a lot going on between them. Does that make sense? Once you've got it on there and you can see it, what you start drawing. Leave it where it is and start drawing.
I don't think it'll work. Oh.
Here's your picture.
Okay.
He has a gun.
Some of you are seeing different things happen in between your magnets. Somebody who has a north and north drawing, raise your hand. Let me see your north and north drawings. Let me see those north and north drawings. Trevor Elliott, go draw your north and north drawing on the board. Put a north and north drawing on the board.
Awesome.
Go. Who has a north and south drawing? Let me see him. Let me see him. Let me see him. Tyler, let me see it. North and south. Cheyenne, go draw your north and south drawing on the board for me, like Trevor. North and south. Trevor's doing north and north. You need to go draw for me north and south. Okay. No, you can just draw it. All right, I have a question. What did you see between north and north? What did you see there? Look at your drawing. What did you see at north and north? Talk to the partner across from you. What did you see? What else did you notice?
Together.
north. What? Listen to what he saw.
Also, the iron shavings still making shapes around them.
Around what?
The magnets. But there was a gap between it because the forces don't want to go together.
Did you see that? There were still iron shavings around the magnets, but between the two north magnets, there was a big gap. Because those iron shavings, they didn't want to go together. Because those magnets aren't pulling together there, they're pushing them apart. So the iron shavings were pushing apart. Talk to each other about north and south, what you know. I like how this table's using scientific language to talk about it.
I would agree that
What you notice between the north and south?
Rice.
that it took for shaving and
It collected more shavings. Why? And weighed them.
it
All eyes on breast.
maybe because it's north and south. Maybe maybe the two were trying to stick to each other.
What is that word? They were. Anybody help them?
Attracting?
Attracting. Good.
They were attracting.
They were attracting. Okay.
So it probably made the force stronger and one more shaving.
Oh my goodness, did you hear that? They attracted, and it probably made the force stronger and attracted more shavings. You see that there was an invisible force between the magnets where those shavings stuck? Whereas in the north and north, there was not a force between the magnets, so no shavings stuck there. Did you see that?
Yes, ma'am.
Yeah? Okay, what I want you to do is I want you to turn the page over, and with your partner, draw conclusions. Write about those things that you noticed. Write about why.
Why? Draw conclusion.
Why do you think the iron shavings created the patterns that you created?
We asked about the ball.
You know about the
There was more, like, and there was a space.
Well, like I said, north are so strong, so they get together. I think I think that you're pushing this by yourself. Something. Are you pushing this by yourself?
You can do it with your partner. Talk about it. And answer this one question. Just this top one. Answer just this one question right after you draw the conclusion.
The force got weaker because I was just thinking, I think that they just focused on each other. Yeah, besides the iron shavings. Because like they didn't want to go together, so they didn't really like from the iron shaving.
Grace is talking to her partner. Jason and Cheyenne are talking to Lisa. Write about what happened and why.
Because they actually tried to get besides just helping.
No, we're not doing
Yeah,
this.
there was some
We're not doing this.
as much before because they were help drop
You may draw and write. Yeah, you have to write. I want to see drawings and writing to show and explain what happened. I'm going to give you
She said you can do this solo.
3 minutes.
Solo, you know, by yourself. Yeah. She said you could.
trying to talk to you.
We can write
I like the Bryce is writing. Talk to your friend. Talk to them. Ask them. You're trying to tell me why those iron shavings happened and how's the magnetic pole?
maybe because since North, the instance from North were separated.
You go with that. Keep going.
Maybe because since North and South are stronger, maybe they made it equal design or
Oh, I like that. Why did that make the shapes that they made? Okay. Bryce, I'm so interested to see what you have to say. Yeah, they would do that. What happened between them? If you need a good drawing, what happened? The two on the board are perfect for what you saw. So are there sharp pencils? Grab one. Thank you. One more minute to finish up. I see some good drawings to help explain. Easy. Make sure you mention what happens between them.
It looks like so. This so. That looks like it's
Oh, guys, listen to what Jabari said. Listen to what he saw.
I said we think that the iron baby created a pattern because at north and south made a magnetic field would come together and there would no gap.
Did you hear him? The north and south made the magnetic field come together, and so the iron shavings made no gap because they were attracted to each other. So iron shavings filled that space up. Okay? All right. Not yet. Don't do the nonsense yet. That's your exit ticket. Okay? Bryce, read for me what you wrote. Yep. Bryce is going to read. Listen up.
Maybe because since North and South are strung together, maybe they made equal design for a pattern. Also, the gap closed with North and South
Because
they go together.
yeah. Oh, did you hear that? I love that you used the word also this happened. That was a really good sentence. Read it for me. Last one.
Because the north and the south poles made a magnetic field. Was pulling the iron in, and the north and north separated the iron.
Exactly right. Guys, I want you to leave your paper where it is and come to the carpet really quickly. I want to show you just a 2-minute video to introduce you to an idea that you'll learn about more. What type of video is it? Come on, 5, 4, 3. Oh, Bryce and Madeline, come on. 2, 1. I like how Jabari's sitting. I like how Hannah's sitting. Cheyenne, scoot up here. Aaliyah, sit down. Madeline, Alexa, sit down. Okay. Okay. Guys, did you know that the Earth also has a magnetic field?
Yes.
Oh, well, okay. Oh, because Miss Scarabelli mentioned it, didn't she, when she asked us about everything we were learning?
And it's also because of the iron core of the earth.
Well, guys. Okay.
Well,
Well, I'm going to show you a video.
I know, so let's just skip it.
I'm going to show you just to introduce, okay? We're going to look at just the magnetic field, and we're going to look at one other idea, okay? Avery, hit the lights for me. Up. Here we go. It's just a 2-minute short thing for an intro. Maybe.
Come on, smart work, cooperate. Keep staring.
Oh, here we go. Ready?
It's a person's hand.
For 3,000 years, man has used the compass to navigate the globe. The Chinese, the Egyptians, all the great seafarers. Without the magnetic needle, they wouldn't have come very far. But where does this mysterious force come from? Just 100 years ago, it was discovered that our planet makes its own magnetic field. The liquid layers deep in Earth's interior generate a charge similar to a power generator that produces electricity. But magnetism is a force which we cannot see or feel. Animals such as sharks, pigeons, and bees can sense magnetism and use it for orientation. For us, the magnetic field of the Earth is still useful because it shields our planet like a huge bubble and protects us from the violent solar winds. On other planets, this constant stream of charged particles from the sun prevented intelligent life from developing.
Did you see there? Did you see there?
One more time.
Did you see there how the Earth's core creates a magnetic field around it? And though we can't see it or feel it, it's there. And that's what explains why compasses work, because they're attracted to the north pole of the magnetic field, okay? There are so many more experiments to do about compasses and the Earth's magnetic field. We just had to look quickly at it to see, so in the future that we understand that there are magnetic fields and they can be used. So if you're ever experimenting with a compass, now you can blow your parents' socks off and say, Mom and Dad, I totally know why. I totally know why this compass works. The Earth is magnetic. It has its own magnetic north pole and south pole. Just like magnets have their own magnetic field, the Earth has its own magnetic field. Okay? That's just a little extra tidbit for you today. I want you to go to your desk. You have an exit ticket. Just one question exit. Show me what you understood today. Draw for me your magnetic field on there for your south poles and write about why it looks the way it looks. Okay? That's your last task. I want to see if you can do that 100% silent. Go.